Okay, so we are going to demonstrate a full automation loop for a foot rotor vertical takeoff drone. Right here we've got Real Flight Evolution, which will act as our physics simulation software. It will provide sensor input data to our virtual flight computer, which will then feed back control commands in response to stabilize and whatnot. The full screen on the bottom right here, we've got this will be a computer that's acting as our flight controller. I've got this on a separate machine, so we're talking over the network to this other computer that's running the physics simulation. We've got the physics up and running. We will go ahead and bring the flight computer online. And once this all tests out okay, we can simply transition from the flight computer virtualized on the computer to an actual physical flight computer on an actual drone. And it will all work the same. Okay, waiting for heartbeat. Let's make sure our physics simulation is still going. Okay. We don't have internet connection on this computer. Okay. Solved. Okay, so we now have the flight computer is sending commands to the drone. In this case, since it doesn't need to be doing anything, motors off. So now it's ready for our... Let's make sure our connection's solid. Yeah, we're good. We're good. So now I'm going to get our laptop ground control software connected to the drone. In this case, they do happen to be on the same machine, but once we move to a physical drone, the laptop would connect through the controller handset and send commands to the drone through that telemetry radio, and also receive telemetry back, so we can track it.
Initializing flight mode. Skipping INS calibration. Manual flight mode. Quad plane loiter flight mode.
Skipping INS calibration. It is not happy about something. Let's see. Okay, now it's connected. It's got some boot up. It needs to finish, so we'll let it finish booting. And it looks like it's ready. I had a flight plan prepared, but I'm gonna have to start that over. Shoot. Okay. So we're just gonna do basic corridor scan with a couple waypoints in between. So we can test out in-flight mission changes, you know, if we want to, on a whim, decide to send the drone to loiter at a certain point. So here we'll start off specifying our takeoff altitude. We're going to take off to 40 feet. And then at 40 feet, we will switch to plane mode, and those front rotors will tilt forward and it'll start doing forward flight. We're going to do our mission at 100 feet. And set our landing. Great. Done with that. So now we're going to make some intermediary waypoints just so we can climb up to desired altitude. Get up to 100 there. After the corridor scan, we'll add 2 more waypoints. Well, 3. Let's reorganize those a little better. Okay. Let's see, all at 100 feet. When we're getting back into our loiter for approach, we want to get back down to 40 feet. In fact, we'll put that a little closer to, that's as close as it wants to get. Okay. Don't need to have that long of a, okay, so we got our waypoints all set to the altitude we want. We're going to upload this flight plan to the drone, and then we can have it take off. Okay, uploaded. We are ready to begin the mission. So we'll go ahead and give the command to start. Climb up to about 40 feet, and then switch into fixed wing. Ooh, a little high that time. Probably because it needs to climb. That's weird. I shouldn't have done that, I don't think. But it doesn't hurt anything. Okay, so it's about reached mission altitude. Airspeed steady. We'll see if it maintains that. Steady airspeed. So we can adapt this model to another aircraft. You know, we just have to adjust motor positions in the model itself and aircraft weight. But then we should just be able to swap out the virtual drone for a real one. So all the while that it's doing this, it's sending commands to the onboard camera to, well, it would be. I didn't actually do that because we don't have a virtual camera, but the drone mission would be programmed in a way that it would tell it to take photos every, you know, however many feet or seconds you want it to take a new photo as it goes. Saves it to the onboard computer. It plugs in the GPS telemetry data into the metadata of each photo so that you have exact coordinates of where each photo was taken. When this is all said and done, we can take that collection of photos off onto another computer and run it through a photogrammetry calculation. And that will stitch together all the photos and create a 3-dimensional geometry which can be directly overlaid onto something like Google Maps to create very, very detailed 3D maps of an area. So there's some places, if you look at Google Earth, there's some cities that do have full geometry, like every tree has shape and form. This is how they do it, maybe not with drones, but with satellites. A lot of time with drones, to get the high quality photogrammetry, it really does require a plane or a drone to do that. Okay, so it's the last leg of our corridor scan, so it's going to start going to waypoints. And in the flight computer, I'm going to see if I can't just tell it to loop back to waypoint 20. I haven't played a lot with the commands in there, so I want to get used to how that works. We have a full-size drone for actual missions up and running. We'll probably have a separate computer like a Raspberry Pi to kind of handle all the bigger picture type tasks. Okay, yeah. We could use the... Oh, why didn't it go all the way? Yeah, we can use the onboard command system, or we can use the ground control station software, which communicates using a protocol called Mavlink. This one should actually go all the way to the waypoint that I told it to. Alright. If I wanted to have it loiter at a waypoint, let's see. We'll have it get back to 22 and then just loiter for a bit. So far, not quite ready for it to come down.
Loiter flight mode.
Loiter. And so now I should just fly around in circles and hold at altitude where it is. Nice. Okay, we'll resume course.
Auto flight mode.
Switching to auto. Let's do quad plane loiter. Watch it.
Quad plane loiter flight mode.
I see the battery consumption going down quite a bit from that. Yeah, it takes a lot of power to get these planes to float. They're heavier than your typical quad plane. Or your typical quad rotor. Okay. We'll go back into auto.
Auto flight
let
mode.
it land itself. Oh. That wasn't supposed to happen. Oh, messed something up there. Let's see, what do we do?
Takeoff flight mode.
Weird, it just fell straight down. Yeah, I gotta be careful switching between vertical takeoff modes manually. $162 feet, that's pretty high. Why is it doing that? Okay, we're gonna continue the
Auto
mission.
flight mode.
What does it think the next waypoint is? Waypoint set 23. We'll do a proper landing this time. Thankfully our virtual drone does not take damage. At least not when it lands nicely on its belly. And it's at 40 feet. I should start transitioning back. Got this nice balanced transition stage with the tiltrotors kind of at 45 degrees here. So it's going to just be as happy with going vertical. have to keep playing around with issuing manual
Disarmed.
overrides. So we don't want to be crashing like we just did. Cool. That is that.